All right, we'll get started. So welcome to the vBrownbag session here in Sydney VMUG. I'd like to thank Alistair and the VMUG team for inviting me and giving me the opportunity to speak to each one of you about streamlining your IT transformation, so mouthful here, with traditional and modern storage, software-defined storage architectures. My name's Stephen Lee. I'm an enterprise technologist with Dell, focusing on virtualization and software-defined data center. Okay, so many of you may have faced this today. We're going through a sea of change. Okay, so workloads, applications, where people access information, you hear buzzwords like big data, DevOps, cloud. Everything is fundamentally changing the paradigm of storage needs and storage capabilities, and therefore questioning the underlying infrastructure that is delivering that today, and how could that evolve into the future. And so what we're really going to explore today is a bit of the architecture, but more importantly, from a VI admin perspective, how do I deal with this change? How do I interoperate my existing storage that I have today, which I've got to potentially protect from a replication perspective, protect from a data protection backup or archive perspective? How do I transition my workloads to the newer architecture by leveraging policy-based framework is what we're going to uncover today. So we're going through this shift between traditional and new IT. So what are some of the storage capabilities that is delivered today with your legacy storage arrays, 3-tier architecture, so you've got servers, you've got networking, and you've got storage. They've had advanced capabilities around data reduction, data efficiency, data optimization. I mentioned the data protection and disaster recovery as well. But what new IT, so what we're seeing in modern software-defined architectures is the ability to scale out. You're not tied to a pair of controllers and its internal capabilities around memory, cache, and processing. You scale out by adding more compute and storage nodes to deliver that application and workload requirements. It's really built around no RAID or erasure coding, and many of the different software-defined storage providers provide that today. And from a form factor perspective, we're seeing this sea of change around convergence or hyperconvergence. So ability to have compute and storage all within a 2RU form factor where you can deliver a cluster of multi-terabytes or tens of terabytes of storage while still being able to deliver the compute environment required from a vCPU and a vRAM perspective. And then one of the other capabilities, which some of the more, modern traditional storage has, but definitely what software-defined offers, is the API-based management and provisioning capabilities. So the ability to move workloads, integrate with tools like the Cloud Management Suite, vRealize Automation, vRealize Orchestrator, and other storage platforms which allow you to move data from your on-premise solution to an off-premise cloud, giving you that hybrid cloud capability, not only just to back up the data, but also to be able to spin up those workloads in the cloud as well. The other components which new IT or software-defined helps deliver is multi-tenancy and time to deployment. So not having to go through the rigor of going through each individual component around compute, around networking and storage, and ensuring that you meet a certain HCL, it's delivered as a hyper-converged appliance typically, and then you're able to deploy that in minutes and hours as opposed to days and weeks. So your time to value is critical. Now, if you break down software-defined storage in its own, there's multiple different applications or current deployment methodologies. The first one is the physical appliance. So it's a traditional storage array, which actually has SDS-like capability. All right, so programmability, API, VM-centric, VM-aware, all those buzzwords that you start to hear. Some of the existing storage arrays can do that today with integration that we'll demonstrate a little bit later. And then you've got more upmarket, new players in the market that are delivering hyperconvergence. So we'll talk about VMware's vSAN solution, but there are other vendors in the market that are also delivering the hyperconvergence, focusing on software-defined. And then the third deployment methodology is around software only. So delivering it software, being able to integrate it with compute and storage resources in the back end, but effectively you're running a software as an appliance or a software only model. Where we see predominantly the market today is obviously there's interest in hyperconvergence and software-defined, but there's still obviously many petabytes of traditional storage arrays out there that are being managed by yourselves today that will continue to be managed in the short to medium term. So how do we bridge that all together? Because from our perspective, it's not really a all strategy. No organization or business can afford to divest their investment in their current storage infrastructure and completely cut across to the new IT and deliver software defined. So it's really about bridging that stage where we want to get the best out of what we have today. Can we tune it and tweak it and get some increased capabilities and some better manageability? And then how do we use policy-based management or framework to actually orchestrate workloads to be able to seamlessly be deployed across different disparate storage architectures, which is the core part of today's demonstration. Net, there's no one solution fits all, right? Everyone's, I'm sure you've been customers or been aware of VMware for many years, so the journey that VMware have been touting for quite a while, each one of you are at different stages of that journey. And it's no more prevalent in the way storage is really starting to adopt all these software-defined capabilities. So there's traditional VMFS storage and NFS storage, which we've been familiar for quite a while now. And what's most recently been added into the portfolio over the last 12, 18 months is vVOLS-based capability. That's basically giving your traditional 3-tier architecture a bit of a speed bump, if you like, from a performance, but also from a manageability perspective. But also over the last 12 to 18 months, VMware's Virtual SAN or vSAN has matured greatly, where they're at the point of, I think they're about to GA 6.2 and new capabilities around data reduction and also performance limiting capabilities are all part of the broader ecosystem of what VMware are able to deliver with their software-defined strategy. Underpinning all that is that middle piece, that's storage policy-based management, or SPBM. Okay, so you'll be able to manage vVOLS-based storage, you can manage virtual SAN storage, in fact, you can even manage NFS and VMFS storage as well, but leverage that framework. So that requires change. Change in potentially your process in which you orchestrate your machine provisioning, right? And we'll go through a demonstration of those capabilities and giving the VI admin the ability to be able to define the right storage characteristics and capabilities for the appropriate workloads that are being delivered for the business. So before we jump into a demo of SPBM, the new features that enhance traditional storage arrays is vVOLS, right? It's not new, it's been talked about for probably 5-6 years from VMware, and finally we have an implementation today with vVOLS. Effectively, it takes the construct away from LUN-based or volume-based management. Now you get VM-centric management, VM-centric data services. What I mean by that is, rather than traditionally having to snap an entire VMFS to create a snapshot for your virtual machines, you're now snapping the individual virtual machine, or you're replicating the individual virtual machine. It gives you far more granular data operations and data recovery capabilities. Okay? It also introduces per VM data policies, granular storage policy-based management, which will be a core part of the demonstration. A key component here is the VASA 2 provider. Right? So to enable these features in vVOLS is VASA 2. Prior to VASA 2, VASA 1 was a one-way communication from the storage array. Right? So we'll bubble up the capabilities from the storage array and say we've got RAID-protected storage, it's snapshotted, it's replicated. All right? We'll bubble that up to the VI admin, they can see that. But with VASA 2, not only do they see those capabilities and more with the VASA 2 capabilities provider, but you also have the ability to instruct through an API framework those operations that are traditionally being managed by storage. Right? For example, a clone operation, we traditionally have to read from a VMFS and then write it back to a VMFS traditionally. Now with the VASA 2 provider, we actually make an API call to the storage array and immediately do a storage array clone. And so we're talking about significantly reducing the time for deployment of virtual machines. Okay, that's one of the additional capabilities of VASA 2. Let me just go into, sorry. Jumped right to the end, apologies. Okay, I have a video, sorry, next one. Do we have a, top of list, yeah, got it. There we go. So I'm gonna have to narrate this, so I'll try to walk you through as we. So first of all, what I'm going to go ahead and do is give you a quick underneath the covers view of the underlying infrastructure that is used for this demonstration. Yep, it's slowly walking its way through. Effectively, as you can see, it's a web client. What I've got in the back end is Dell EqualLogic iSCSI storage. I've got Compellent iSCSI storage, and I also have VMware vSAN storage. Okay, as I navigate through this demo, we actually get to see the different infrastructure this? There we go, slowly working. All right, so we've gone to the data center, we've looked at the different clusters. We're going to look at two clusters today, the customer POC cluster, and then with this demo, we're also going to look at the vSAN cluster. As you can see, there's 3 nodes in the vSAN cluster. And shortly, we're just going to examine some of the capabilities within vSAN. So there we go, we've got 3 hosts within vSAN. We've got 6 eligible flash devices for your read-write cache. Then we've got 12 persistent data disk, which gives you roughly about 10 terabytes of usable capacity for your single vSAN data store. And then what we're going to examine now is the different storage arrays. So the first one, we're going to the EqualLogic plugin here. So EqualLogic iSCSI plugin, there's 6 storage arrays, okay, on the left. And then there's 4 pools of storage, which has been defined in this group of EqualLogic arrays. Mixture of drives, mixture of different RAID types that are available in this EqualLogic storage. Then we're going to go navigate into the compellent plugin. And then just give you a quick view, I think there's about 5 compellent storage arrays here. We're going to use 1 for this particular demo. So compellent 3, 2, 1, 5, and 6 have been exposed to this vCenter environment via the plugin. However, we're going to use the compellent 3 as the target device for our traditional VMFS storage. EqualLogic will represent your vVOLS storage, and vSAN will represent your new software-defined storage. So now that we understand the infrastructure, now let's talk about the new storage policy-based management, which is available within vSphere. So I've defined, so they're user-defined storage profiles here. CML denotes compellent, equal denotes EqualLogic, and then you've got the default vSAN storage policies there. I'll drill down and edit the storage policy to give you guys an understanding of how the rule sets are set up. So that's user-defined, and then I've added a description there. What are the capabilities that have been bubbled up from this particular VASA provider? And I'll click on the compellent VASA provider there. It's basically providing VASA 1.0 capabilities. And the system label basically is a capacity-based storage array with multiple different RAID types. Okay? And then what it will go ahead and do is then scan for, within this data center, which are the compatible storage backing devices which I could use. Okay, in this case, I've got 2 storage devices. I'll use the second one as the target one later. You look at the incompatible, so these are all the other data stores that don't meet these capabilities. Okay? So that's the compellent capacity single tier storage policy. It's about a terabyte of VMFS 5 storage. Next one, I'll actually go into the vVOLS data store, vVOLS storage policy. And we'll have a look at the different rule sets. So I've just defined it as EqualLogic hybrid vVOLS, hybrid-based storage, flash and hard drives. And then I'll examine the rule set. So this uses, I use this type as a limiting factor. It uses VASA 2, which I'll actually have a chance towards the end of the demo to show you where you find the VASA 2 provider. And then it will examine the storage vVOLS data stores which meet this requirement. In this case, it was a single vVOLS data store, about 100 gigs worth of capacity that was provisioned prior to the demo or for this particular demonstration. And then the third one is just having a quick look at the default vSAN storage policy. So as you can see, it's grayed out. It's a default one set up by vSAN. So failures to tolerate, so number of copies basically of my objects I need, the number of disk drops per object, whether or not I need forced provisioning, object space reservation, and any flash read cache reservation if I wanted for this particular storage policy. And then I'll scroll down, it's roughly about 10 terabytes, as I mentioned a little bit earlier, of vSAN data store capacity. So they're your storage profiles that are available, or storage policies. Used to be known as storage profiles, so now they're known as storage policies. What I'm going to go ahead and do is have a look at the VASA provider here. So I'll go to the vCenter server and then look at the different VASA providers that have been synchronized with this vCenter. So SITV is the compellent VASA provider, and I'll scroll across and you'll see that there's VASA 1.0. There's multiple storage arrays underneath that. Scroll down to the vSAN, so it's 1.5 is your VASA provider there. And then the last one for EqualLogic is the VASA 2 provider. That's where you get the two-way communication. So the ability to execute API calls to the storage array to do things like storage clones for VM deployment. Next step through the demonstration, basically I'm going to do a basic task of deploying, but leveraging the storage policy-based management framework. So historically, when you deploy a VM, you'll need to go have a look at which which data stores I should deploy to. But I don't know those capabilities historically. But because I've got these policies that define capabilities, I now have the ability to define the storage policy, then select the corresponding data store with space to deploy that virtual machine. So I've jumped ahead a little bit, so I've narrated ahead, but that's basically what I'm doing here. So I'm deploying a virtual machine from template. For demo purposes, obviously, keep it a small one, so a little Linux VM. It's about 3 gigs, I think, of space. I'm just call it SPBM test VM 01. And then I select a cluster or ESX host. And this is where the change happens. So now you can apply the VM storage policy. Okay, and you can click down and look at the different policies that are available which correlate with the policies that were defined earlier. First one, we're going to deploy it on traditional storage, so VMFS 5 storage. So it's connected to your compellent using VASA 1 provider. It's going to go through the process, deploy that, and then what we're going to go do is migrate it from VMFS, move it to vVOLS, and eventually move it across to a different host and into the vSAN environment as well. You will notice, for demo purposes, it's not a powered-on machine, so there's no vMotion stuff happening, so therefore it sort of speeds up the whole demo process. But nonetheless, the concept is the same. As long as you've got a valid vMotion network, then obviously the data and the virtual machines will move across the respective hosts and storage. So I think I'm just running some tasks in the background, just waiting for the deployment process to continue. Okay, so I've deliberately created a different storage policy here. So if your data store doesn't either have VASA provider integration or the VASA provider capabilities are not defined today for the particular storage device, you can actually create an alternate method to be able to implement storage policies. So in this case, I've actually used a tag. So I tag this particular data store with certain capabilities, give it a descriptor, and define what it is. So when the process has changed for administrators to deploy virtual machines in this method, that other nondescript storage array or storage device, which is not part of the tighter integration, can actually still be part of the whole framework, because I just give it a tag and give it some capabilities and go ahead and deploy it, just like I would deploy a VM as we deployed earlier. So I'm not going to finish the deployment, but I'll give you a view of what it looks. Same thing. Deploy virtual machine template. Use the same Linux virtual machine. Just give it a test VM 02 or something, I believe. Yep, use the same ESX host. And in this case, I'm presenting it to a data store, which is basically leveraging tags as opposed to the native data services which are presented via the VASA provider. Yes, I don't deploy that. Just to walk through what it would be like if you were trying to deploy, leveraging the same framework to deploy on a different storage backend. Okay, so the deployment's happened. It's now sitting on the compellent storage policy. So you can see there on the right-hand side, compellent capacity single tier storage. If you scroll down a little bit to the bottom, you'll see the data store it actually resides on, which is the SC4020 volume. And then I'm just going to migrate. First of all, the first task will be migrate from VMFS to vVOLS on the existing host, so the same ESX host. I'm going to change the storage policy. So I know exactly what capabilities this storage or this VM requires. I'm going to just leverage the hybrid vVOLS storage policy, and I'm just going to go ahead and migrate from one storage data store to another data store. And then shortly you'll see that the storage policies have changed, and initially it'll be non-compliant because it hasn't done a compliance check. You just do a compliance check and to validate that it is, there we go. So it's done, it's non-applicable. You click on compliance check, you'll check it for the first time and validate that the virtual machine has the right storage capabilities as defined in the policy. There we go, it's fully compliant, and you see down the bottom what actual backing data store it's connected to. Okay. Certainly not rocket science here, but certainly a policy-based framework that gives you the ability to see, deliver the right performance and storage capabilities that the VM requires. This happens to be the EqualLogic Group Manager, which is your UI to EqualLogic, and it actually has a granular view of the virtual machines, the actual VMDKs that are sitting on the back-end vVOLS data store. Lastly, the last exercise is the full transformation. So going from VMFS to vVOLS, and lastly moving to software-defined storage, and in this case leveraging vSAN 6.0. And you notice that if it's just existing storage policy, there's no compatible storage. And then I need to make sure I select the right vSAN storage policy. Click off next, and it's going to go ahead and migrate the workload and also virtual machine to a different ESX host. Now pause the demo briefly as it went through. Didn't take very long. Took about 50 seconds to move it. And then you'll see that it is now applying a different storage policy there. For that same VM, it's transitioned from a lifecycle perspective to different storage, all the way up to modern software-defined storage. Last bit of this demo, I'll just give you an idea where you can actually qualify and locate your VASA providers for your existing storage arrays that you have today. So using the VASA compatibility guides on the VMware website. And then you can locate ESX version, your vendor version, specific VASA providers. For this particular one, I just did a limit on Dell, and you'll notice that there are different providers for different storage arrays that are presented in the demonstration today. There's your different vendors. And it will also give you the version that supports either the one-way communication with VASA 2 or the two-way communication with VASA 2.0. Okay, so we've seen from an operational perspective, day two operations, to change the framework in which you deploy virtual machines so that you can leverage your existing storage today, be it VMFS or be it vVOLS, but also transition at some stage to software-defined if you want a mixed environment of different storage platforms, but using one standard policy-based framework. From a vSAN perspective, there's multiple different ways to consume vSAN. You can even leverage your existing ESX environment, add some flash drives and mechanical drives, and then have a minimum three node cluster, and then build it out and start to evaluate. And that's what a lot of people do from a BYO perspective, okay? Other ways to procure vSAN, if you want to buy an appliance-based model, there's eVo at the end. In the middle, where we find most of the traction is where you've got a supported list, a validated list of vSAN capabilities depending on the number of workloads and the type of workloads, right? And that's all available on VMware's compatibility guide, and which many vendors have published their configurations that you can consume, okay? So just in summary, the VM storage transformation with storage policy-based management, leverage a policy-based framework to enable cross-platform management of traditional VMFS, latest vVOLS-based storage, and then software-defined storage in this case, and it can be third-party storage as well using tags and tag categories. The VASA2 provides two-way interaction between vCenter and storage arrays, improving upon storage offloading functions beyond VAAI. So VAAI was another primitive that provided some acceleration from storage, but with VASA2 it's even faster and more efficient. And the note here, VASA1 only provides capabilities and a one-way communication flow as opposed to the two-way. And lastly, storage policy-based management provides further integration. So if you want to do scripting to automate some of the tasks, or if you've got an investment or intend to invest in vRealize automation and orchestrator, so where you do the cloud management piece, there's actually a storage policy-based management plugin there as well that allow you to provide a catalog of virtual machines with default storage capabilities, but also the ability then for a workflow to be able to change those storage policies that are basically bubbled up from storage policy-based management. Right? So the end-to-end, be it your traditional vCenter management all the way through to cloud management, you can leverage storage policy-based management to really transform your IT infrastructure by leveraging your existing and modern storage. So with that, any questions at all for the presentation this afternoon? I'm out there at the expo on the Dell stand if you want to have a separate conversation. Happy to answer any questions you may have, and how you can leverage what you have today and potentially other platforms to help you ride this wave of change that we're seeing in the IT industry today. So thank you very much for your attention, and enjoy the rest of the day.